In this chapter, we're going to learn about a new kind of probability distribution called the chi-squared distribution. The chi-squared distribution. This symbol here is not an X, it's actually the Greek letter chi. So this is a chi-squared distribution. And like a t-distribution, there are different kinds of chi-squared distribution. It depends on the degrees of freedom of the distribution, what kind of distribution you get. The mean of a chi-squared distribution is actually equal to the degrees of freedom. And the standard deviation is equal to the square root of 2 times the degrees of freedom. Now, if you want to get technical, what the chi-square random variable actually is it's a sum of independent squared standard normal random variables. So it's one standard normal variable squared plus another standard normal variable squared, and you could keep on doing this however many times you need it. So that's the technical thing of what's happening. We're still kind of using that standard normal distribution if you look deep enough. Okay? But the chi-squared distribution is a little different than the standard normal distribution. It is, unlike the standard normal distribution, unlike the t-distribution, it is asymmetrical. So let's get a picture going here. Look at a few different chi-squared distributions depending on the degrees of freedom. So here's 3 different chi-squared distributions with 3 different degrees of freedom. So this has degrees of freedom equal to 2, and the mean is the degrees of freedom at 2. This chi-squared distribution has degrees of freedom equal to 8. The mean is 8. And this chi-squared distribution have degrees of freedom equal to 24. The mean is equal to 24. You could see that the values of a chi-squared distribution are always positive. That's because it's the sum of these squared things. And whenever you square something, you get something positive. Okay? And so that's why the probability density function only exists on the positive part of the axis. You're only plugging in positive numbers here. Like any probability density function, the total area under the curve is equal to 1 in each case. Okay? And you'll notice the shape kind of shifts to the right the more degrees of freedom you have. Okay? We calculate the probability of a chi-square distribution pretty much like we always do. We're going to use our calculator, our R calculator. And to calculate the probability, use P, and then we use chi-squared. So CHI is how you spell the Greek letter chi in English. And then SQ is an abbreviation for square. And then we give it the quantile value, which would be the chi-square value for a chi-square distribution. And then we specify the degrees of freedom. This is going to give you the probability in the left tail of a chi-square distribution. So if this is a chi-square distribution and we have a quantile value that's maybe right here, this might be our chi-square value. If we plug it into this function, it's going to give us the area by default in the left tail. If we want the area in the right tail, or the area in between 2 values, we need to do the same arithmetic as we do when doing that kind of procedure for a normal distribution or a t-distribution.